Hello everyone. Now we will see the complete time domain analysis of second order system. So in this second order system, these things can be asked to you. IR1, IC1, IR2 or IRC2 both are equal. We note VC1 and VC2 and VR1 and VR2. So we will see the waveform of everything. Okay. So let us start. Okay. So you need to listen it slowly and just try writing down in your notebook as well. Okay, I will give you the notes, but try writing down in your notebook as well. Then only you will understand. It's a complex concept. Okay, not very straightforward. So t equals to 0, capacitor will be short circuited, right? So your circuit will be something like this. Capacitors are short circuited, right? This is V in here and this is V0, R1 and R2. So here we have V in by R current flowing, right? So V in by R current flows through C1 and C2. It charges both of the capacitor, right? Capacitor are short circuited, so V in by R2 current. Okay, so V in by R2 current is flowing, so that charges both of the capacitors C1 and C2. So initially at t equals to 0, Vc1 at t equals to 0 is 0 volt, right? Vc2 at t equals to 0 is 0 volt. VR1 is equals to Vc1 at t equals to 0 is 0 volt. VR2 at t equals to 0 is 5 volts, right? VR2 is 5 volt, right? This 5 volt is coming, so VR2 is 5 volt. IR1 is 0. IR1 at t equals to 0 is 0 volt, 0 ampere, right? And IR2 at t equals to 0, that means your IC2 at t equals to 0 is 5 by R ampere, 5 by R2 ampere, right? This 5 by R2 current is flowing. This 5 by R2 current is flowing from this capacitor and R2 and C2. In R1, this is providing some resistance. So in R1 there will be 0 current, right? IR2, right? And in IC1 at t equals to 0 is 5 by R ampere, right? Now, since C1 is getting charged, right? This C1 is getting charged, and because of that some voltage is developed. If C1 is getting charged, some Vc1 is developed, some Vc1 is developed. Since Vc1 is equals to VR1, that means some voltage across the resistance is developed, right? Look, C1 is getting charged, so this Vc1 is developed. Since this Vc1 is developed, there will be some voltage across this R1, and because of that there will be some current flowing through the resistor. Capacitor getting charged, some voltage is developed, and because of that voltage some current is flowing. Okay, so because of that some IR1 will be there, some IR1 will be there. Okay, so there will be some finite IR1. Okay, now what is your V naught? Your V naught is V in minus Vc1. V naught is V in minus Vc1. Okay, V in is constant and Vc1 is increasing. Vc1 is increasing. So because of that, your V0 goes down. Okay, and since C2 is getting charged, by I2, IR2, that means Vc2 is increasing. Okay, C2 is getting charged by R2, so Vc2 is increasing. Now what is VR2? VR2 is V0 minus Vc2, right? Because of this IR2, this C2 is getting charged, so Vc2 is increasing. So this is increasing and V0 is decreasing. So your VR2 will go down. V0 is decreasing and Vc2 is increasing. So your VR2 will go down. That means here V0 is increasing. I shouldn't put this one. I should write here V0 is increasing and Vc2 is decreasing. That means VR2 goes down. If VR2 goes down, that shows IR2 goes down. So eventually your IR1 is increasing and IR2 is decreasing. Okay, so what we have seen till now, look, initially capacitors are shorted, so there is V by R2, V in by R2 current is flowing. Since V in by R2 current is flowing, C2 is getting charged and C1 is also getting charged. Since C1 is charged, there is some voltage developed across the resistance, and because of that current, because of that voltage, there is some current flowing in the resistor. That is IR1. Okay. Since the capacitor C1 is getting charged again, getting charged, then this VC1 is getting increased, and then your VR1 is also getting increased. So the current is also getting increased. So your IR1 is increasing. Since your VC1 is increasing and your V0 is V in minus VC1, your V0 is V in minus VC1, your VC1 is increasing, then V0 is going down. Also, your VC2 is increasing. So your V0 minus VC2, that is equals to VR2, that is going down. This is VR2. This VR2 is going down. That means your current IR2 is going down. So eventually your current IR1 is going up and your current IR2 is going down. And also your V0 is also going down. Here your V0 is also going down. IR1 is increasing, IR2 is decreasing, and your V0 is going down. And both C1 and C2 is getting charged. Okay, so some students get confused in one concept, like they say that IR2 is decreasing, so C2 is discharging. They say that IR2 is decreasing, so C2 should discharge. No, this is not the concept. Look, we will see one general concept. Here what is the waveform of I0? Initially 5 by R and then it goes down, right? This is I0. And what is V0? I have to record the video turning off all the fan, and it is very humid here, 50-degree temperature. Yeah, so your V0 is getting increased from 0 to 5 volt. Okay, so even if the current is going down, the V0 is getting increased. The current is going down, but V0 is getting increased. So current can go down and be positive. Then capacitor will still charge. So the capacitor is charged until the current is positive. Even if the current is going down, there is no problem. The current is getting less. Till that time it is fine. If the current goes negative, If the current goes negative, then the capacitor will discharge. If the current goes in this direction, at that time the capacitor will discharge. Okay, so till the time when there is positive current, no matter if it is increasing or decreasing, the capacitor will still charge. Do you get this point? Okay, so this is very easy point, but many people get confused. This is very general point, everyone knows. So if current is going down but it is still positive, the current can go down and still be positive. Okay, current can go down and still be positive, then the capacitor will still charge. Okay, so this is a simple point. Both C1 and C2 are getting charged, so your IR1 is getting increased and IR2 is getting decreased. Okay, yeah. So now where are we? What we are seeing is that your current IR1 is going up and IR2 is going down, and your V0 is going down. Okay, so at some point your IR1 will be equals to IR2, right? Your IR1 was going up and your IR2 was going down, so at some point both current will be equal. Now if IR1 is more than IR2, what is IC1? IC1 is IR2 minus IR1, right? Just see here, IC1 is IC1 plus IR1 equals to IR2. So your IC1 is IR2 minus IR1, right? So your IC1 is IR2 minus IR1. So since now this is the case, if so, now if IR1 is greater than IR2, IC1 will be negative. That means C1 discharges. If C1 discharges, VC1 goes low. Okay, and what is V0? V0 is V in minus VC1. If VC1 goes low, if VC1 is decreasing, that means your V0 is increasing. Did you get this point? If your current is getting, if IR1 is getting more than IR2, IR1 is more, IR2 is less, then the current IC1 will be negative. That means first the current was flowing in this direction, IC1, now the current is flowing in this direction. Now the current is flowing from right to left. IC1 is flowing in this direction. I should show you with the diagram. Now your current is negative. The current is flowing in this direction. Now the capacitor is getting charged in this direction. That means the VC1 is going down. Okay, the current is getting charged in opposite direction. That means VC1 is going down. That means your V0 is going up. Right. So at the moment when IR1 was equals to IR2, at that moment your V0 was minimum. When your IR1 was equals to IR2, at that point your V0 was minimum, because after that your V0 is increasing only, right? So when IR1 was equals to IR2, at that time V0 was minimum. Okay, when IR1 was equals to IR2, your V0 was minimum. Okay, now what is happening is that now when IR1 is greater than IR2, your V0 goes up, right? Now the current IR2 is is less than IR1, but it is still positive, right? The current is lesser but still positive. That means your C2 will still charge. So the concept that I have explained earlier, right? The current is less, the current is going down, but still your capacitor will charge because it is positive. The IR2 is lesser than IR1, but still it is positive. So C2 will still charge. Okay. Now what is VR2? VR2 is V0 minus VC2. V0 is going up. Also VC2 is going up. What about VR2 now? Your V0 is going up, right? Your V0 is going up. Here I have explained V0 goes up. So V0 is going up, and also if the current is positive, that means the capacitor C2 is getting charged. That means your VC2 is going up. V0 is going up, VC2 is going up. Now what about VR2? We will see it now. Okay. Your capacitor C2 is getting charged with the current IR2, right? Capacitor C2 is getting charged with current IR2. What about C1? The C1 is getting discharged with current IR1 minus IR2. Sorry, IR2 minus IR1. The capacitor C2 is getting charged with current IR2, and the capacitor is getting discharged with current IR1 minus IR2. Okay, IR1 minus IR2 because IR1 is more. So it is getting discharged with current IR1 minus IR2. Okay, so let me write it. Capacitor C2 is getting charged with current IR2, and capacitor C1 is getting discharged with current IR1 minus IR2. Okay, so the current flowing in this direction is IR1 minus IR2 in this direction. This is capacitor C1, and here I can draw. This is capacitor C1, and the current flowing in this direction is IR1 minus IR2. Okay, so the current flowing in C1 is IR1 minus IR2. In this direction we have IR1 minus IR2 current. So your C1 is getting discharged with current IR1 minus IR2, and C2 is getting charged with current IR2. Okay, so now what is getting charged more? So C2 is getting charged more and C1 is getting discharged less, right? Because IR2 current is more and IR1 minus IR2 current will be less, right? This is a pure independent current IR2. Now this is the subtraction of two currents, right? So surely the current IR2 will be more. IR1 is greater than IR2, but IR1 is not greater than 2 times of IR2, right? It is not greater than 2 times of IR2. It is greater, but it is not greater. It is not so much greater. So your IR2 is greater than IR1 minus IR2. IR2 is greater than IR1 minus IR2. That shows C2 charging is more than C1 discharging. Right? C2 charging is more than C1 discharging. What is V0? V0 is V in minus VC1. Going less down. Right? If VC1 is discharging less, that means if C1 is discharging less, then that means VC1 is going less down. That means V0 is going up, but going less up. Going less up. Look, C1 is getting discharged, but it is getting discharged lesser than what is C2 is getting charged. So your V0 is going up, V0 is surely going up, but it is going up with a lesser rate than what C2 is going up. Look, there is no point I can make you understand it so much clearly. You have to think, you just think it. Okay, VC1 is going down, your VC1 is going down because of the negative current. Your VC1 is going down and your V0 is going up. That is certain. But what is the speed? The speed is IR1 minus IR2. The speed is lesser. So your VC1 is going down with the lesser rate. That means your V0 is going up with a lesser rate. So the increase in Vc2 is more than increase in V naught. So that means your Vr2, that is equals to V naught minus Vc2, right? It will also go down. That means IR2 will go down. So your IR2 will always go down. So did you understand this concept? Your VR2, your V0 is going up and VC2 is also going up. So V0 is going lesser up and VC2 is going more up. So if VC2 is going more up, then your VR2 is going down only. Okay. So your IR2 is going down. So and since VC1 is getting discharged, that I told you, right? C2 will still charge. Yeah. VC1 goes lows. If VC1 goes lows, then your VR1 also goes lows. That means your IR1 also goes low, right? Since your capacitor is getting discharged, there here I shouldn't write it. I will write it later on. Okay. Since VC1 is going down, that means your VR1 is going down. That means your IR1 is going down, right? VC1 is going down, that means your VR1 is going down, that means your IR1 is also going down, right? So both IR1 and IR2 is going down. Both are going down, but IR1 is more than IR2. Look, both current are going down, but this is more. IR1 is more. Both current are going down, but IR1 is more. Both can go down, right? But the current IR1 is more. Okay. So if IR1 is more, so both IR1 and IR2 will reach 0 at some point, and at that time steady state will be reached. Now I will explain the complete concept once more. Okay, so you have to listen it very carefully. I am explaining the complete concept once more right from the beginning. So here what is happening is that initially the current C1 is shorted, C2 is shorted. So the current V in by R2 is flowing. Okay. So here IR2 current is maximum 5 by R2 and your IR1 current is 0. And since there is some IC1, because of that your C1 is getting charged, and because of current IR2 your C2 is also getting charged. Okay. Since C1 is getting charged, because of that VC1 value there is some voltage developed across the R1. Okay. And because of that there is some current flowing. Okay. So because of the charge on the capacitor C1 there is some IR1. So now your IR1 is increasing, and since your IR1 is increasing, that means your VC1 is increasing, and since VC1 is increasing, that means your V0 is going down. Your V0 is going down, your VC2 is going up. So because of that your IR2 is going down. So immediately after t equals to 0 plus, your IR1 is going up and your IR2 is going down. Okay. So this is what we have written. Okay. Some voltage, so some IR1 will be there, and because of that your VC1 is going up, and your that means your V0 is going down, and since C2 is getting charged, that means your VC2 is going up, and since VC2 is going up, that means your VR2 is going down, that means your IR2 is going down, and now your IR1 is going up, IR2 is going down, and your V0 is going down. So at some point, if IR1 is going up, IR2 is going down. So at some point IR1 will be equals to IR2. Okay. So at some point IR1 is equals to IR2. Now if IR1 increases more than IR2, if IR1 is more than IR2, so if IR1 is more and IR2 is less, so this IC1 will flow in negative direction. Since IR1 is more, IR2 is less, so this IC1 will flow in negative direction. That means your capacitor is getting discharged. So if the capacitor is getting discharged, that means your V0 is going up. Since IR2 is getting less, IR2 is lesser than IR1, but still it is positive, right? Still it is positive. That means your VC2 is going up. Your V0 is going up, your VC2 is going up. And one more point is that since your VC1 is going down now, your VC1 is going down, that means your VR1 is going down. Your VC1 is going down since the current is flowing in opposite direction. So your VC1 is going down, that means your VR1 is also going down. That means your IR1 is also going down. Your IR1 is going down, your IR2 is going down. But IR1 is more than IR2. Okay. So now the point is here is that your V0 is going up and your VC2 is also going up. Now which one is going more up? So VC2 is going more up because the capacitor C2 is getting charged with the current IR2. Okay. The capacitor C2 is getting charged with the current IR2 while the capacitor C1 is getting discharged with the current IR1 minus IR2. So C1 is getting less charged. Sorry, the C1 is getting less discharged. If C1 is getting less discharged, that means V0 is going up lesser. The V0 is going up, but it is going up lesser. So your VC2 is going up. Yeah. So your VC2 is going up more. That means your current IR2 is going down. So both IR2 and IR1 are going down. Okay. So at some point, both of the current will go down to 0. And at that point, your steady state will be reached. So at that point, if both of the current goes down to 0, at that point, your VC2 will be equals to V0. That means it will be equals to, both current goes down to 0. That means your IR1, yeah, IR1 goes down to 0, IR2 goes down to 0, your IC1 goes down to 0. That means your VC1 goes down to 0, your V0 or VC2 goes down to 5 volt. So at steady state, IR1 will be equals to IR2 equals to VR1 equals to VR2 equals to VC1. All are 0. And your VC2 equals to V0 is equals to 5 volt. Okay. Now we will do the waveforms. Now let us draw the waveforms. First voltages, then current. Okay. Yeah. So talking about VR2 first. Since we have seen here is that IR2 is always going down. IR2 is always going down, right? So from t equals to 0 plus only IR2 is going down. So IR2 is always going down. So it starts from 5 by R2. And in the complete analysis we have seen is that your IR2 is always going down. Yeah, so like this IR2 is always going down. Okay. Now talking about IR1. It will be in brown color. So IR1, it first increases, then after some point both are equal, and after that it goes down, right? Increases and then goes down, but it is always more than the IR1 current, right? Both goes down to 0, right? So this is current IR1. Okay. No, not the current. Current and voltage both are equal, right? Just the multiplication, nothing else. So this is voltage VR2, and I shouldn't have written 5 by R2 here. I should have written 5 volts. So here it was 5 volts initially. VR2 was 5 volt, and then it was going down. So this was your VR2, right? And your this was VR2, this was VR1. What am I doing? This was VR1. So this was VR1 and VR1 was equals to VC1, right? Now talking about VC2. So what is happening with VC2? VC2 initially was at 0 and at a steady state it goes to 5 volt. So VC2 is always increasing, right? So for VC2 we have to take a different color, VC2. So your VC2 is always increasing, right? And talking about finally the V0. So at this point we will have the minimum point of V0, right? And then it will always increase. So at this point we have a minimum point of V0 and then it is just increasing and goes to 5 volt, right? So this is the graph of V0 and this is the graph of VC2. I should use different color. So this is VC2, right? So did you understand it completely? V0 goes from V0 start decreasing and then increase and goes to 5 volt. Starts from 5 volt and goes to 5 volt. VC2 is always increasing from 0 to 5 volt, and VR2 is always decreasing because the current IR2 is always decreasing, and your VR1 first increases, then after some point it starts decreasing because the capacitor starts discharging. So VC1 starts decreasing, so VR1 also starts decreasing. So this is the waveform. Okay. And talking about the current, first we will talk about current IR2. So IR2 will be in green color. So surely it was initially 5 by R2 and it keeps on decreasing, right? So it keeps on decreasing. And then talking about current IR1, that will be in brown color. So that it will completely be same. At this point it will reach its maximum value. Yeah, so this will be your IR1, right? And this was your IR2 equals to IC2. And talking about IC1, this was the point at which it was equal. So your IC1 was always IR2 minus IR1, right? IC1. What is IC1? IC1 is always in this direction. So IC1 initially it was 5 by R2. Then it decreases to 0. Then it decreases to 0 and then it goes to 0 again. Right? Initially it was 5 by R2. Then when both was equal, right? This I can draw with red pen. So at this time VR1 was equals to VR2. So when IR1 was equals to IR2, at that time your current IC1 was 0, right? At that time this IC1 current was 0. So after that it starts flowing in negative direction. IC1 starts flowing in negative direction, then goes to 0. So this is what is happening, right? I hope you have understood the complete concept here. Just revise it once more, then you will learn more about it. Okay, just revise it once more. Now about the second circuit, let me draw it once again. I won't show the complete analysis here for circuit B. Let me draw it now. Yeah, so hello everyone. Yeah, so we are continuing this discussion, like this waveform we have drawn. Now this is the same kind of second order RC circuit, just we have interchanged the RC parallel to RC series. Okay, so both we have interchanged. So again you have to do the same analysis. You have to do VR1, VC1, VC2, VR2, V0, IR1, IR2, IC1 and IC2. So you will do it by your own. Okay, I have spent a lot of time in the previous analysis, right? So that was good enough to make you understand all the concept. It will be exactly the same. So you just need to do the analysis the way I did, initially the current is 5 by R1, IR1 current is 5 by R1 and IR2 current is 0. So by that you have to do the analysis, right? And then you need to draw the waveform. In the handwritten notes, I have given the answer. Okay, here I can't do the complete analysis here. In the handwritten notes, I have given the waveforms VR1, VC1, VC2, VR2, V0, IR1, IR2, IC1, IC2. All the waveforms I have given in the handwritten notes. From there, you can check your answer. And first, you should try drawing the waveform by your own and do the complete analysis. Okay. So there is very rare chance that the interviewer will ask this kind of analysis. This is very complex, but I have taught you this. Why so? Because if you understand this analysis, you will be able to solve any kind of circuit, Okay, we will see one more second order circuit. We will see the complete analysis there as well. So after that, you will be able to solve any kind of first order circuit or second order circuit. Like if you are not able to reach to the final answer, at least you will be able to say something. You won't remain silent. Okay. So these are some important, like not from interview point of view, but to build your understanding of the subject. These are very important. Okay. Yeah. So that's it about the first and second circuit. Now we will see the third circuit. Okay. Thank you. Hello everyone. Now we will see the analysis of this circuit. So here initially at t equals to 0, you have to draw the waveform of all the marked voltage and current. Okay, IR1, IR2, IC1, IC2, VR1, VR2, VC1 and VC2. Okay, and also V0, that is equals to VC2. Okay, so here at t equals to 0, this is the circuit. Capacitor are short circuited. This is R2, this is R1, right? This is V0 and this is V in. The current is V in by R1. Okay, this is at 0 volt, this is at 0 volt. Here your IR2 is equals to IC2 is equals to 0. VC1 is equals to VC2 is equals to 0. IC1 is equals to IR1 is equals to P in by R1. Right? What else is remaining? Yeah, VR2 is 0 and VR1 is V in, that is equals to 5 volts. Right? So this is the condition initially. Now because of this 5 by R1 current, because of 5 by R1 current, capacitor C1 charges. Right? This 5 by R current is flowing through the capacitor as well. Right? 5 by R1 current, capacitor C1 charges. That means VC1 is developed. Capacitor C1 charges. That means VC1 is developed. Okay, your VC1 is developed. And what is VR1? VR1 is V in minus VC1. Yeah, so now since VC1 is getting up, your VR1 goes down. VC1 is getting up, your VR1 goes down. That means your IR1 goes down. Right? VC1 is getting up, that means your VR1 is going down and your IR1 is going down, but still positive. It is going down, but it's still positive. Right? Since VC2 is developed, since VC1 is developed, this VC1 is developed, right? And because of that, assume here we have VC1 and here we have 0 voltage. C2 is charged to 0. So because of that, there will be some IR2 current, right? Since VC1 is developed, there will be some IR2 current. So because of that, IR2 is developed, right? And now IR2 current charges capacitor C2. This IR2 current charges this capacitor C2, right? And because of that, VC2 is developed. So initially VC1 is developed, because of that IR2 is developed, and because of that VC2 is developed, right? What is your VR2? VR2 is VC1 minus VC2, right? VR2 is VC1 minus VC2. What will be IR2? IR2 will be VC1 minus VC2 upon R2, right? VC1 is higher than VC2, right? Why so? Because if this C1 is getting charged, then only VC2 is getting charged, right? First your C1 is getting charged, and because of that your VC2 is getting charged, right? So your VC1 is getting greater than VC2, right? So this shows that your current IR2 is positive, right? So your IR2 increases for some time, then decreases further. Why so? Look, what is your IR2? Again I am writing, it is VC1 minus VC2 upon R2. C2 is getting charged with current IR2. C1 is getting charged with current IR1 minus IR2. Look, C1 is getting charged with this IR1 equals to IC1 plus IR2. Okay, so your IC1 would be IR2 minus IR1, right? No, IC1 would be IR1 minus IR2, because IR1 is equals to IC1 plus IR2. So your IC1 would be IR1 minus IR2. Okay, so your capacitor C1 is getting charged with IR1 minus IR2. Your IR1 is always greater than IR2, because in this case we know that the voltage will always increase. So your IR1 will always have to be greater than IR2, right? Your IR1 is always greater than IR2. Your C1 is getting charged, but that's not the point. That we will come to. We will come to this point in the end. Okay. So what you can see here is that your capacitor C1 is getting charged with IR1 minus IR2, while the C2 is getting charged with IR2. So which is getting charged faster? C2 is getting charged at faster rate, but VC2 will still be lesser than VC1. Look, C2 is getting charged at a faster rate, that we admit. C2 is getting charged at a faster rate, that we admit, and C1 is getting charged with a lower rate. But VC2 is following VC1, right? For some time VC2 was 0, and at that time VC1 had already been at some point, right? If you draw the small waveform here, your VC1 is charging, so your VC1 goes like this. Okay, so this is your VC1. Your VC2 will be 0 for some time and then starts increasing. Now it is increasing at a higher rate, okay, but it will always be lesser than VC1. मतलब वो VC1 से नीचे ही है, बढ़ रहा है VC2, तेज से बढ़ रहा है, अब तेजी से बढ़ रहा है, अब वो स्पीड पकड़ रहा है, लेकिन अभी भी है VC1 से नीचे, क्योंकि VC1 मान लो पहले ही 20 किलोमीटर भाग चुका है और वो 0 किलोमीटर पे ही है, तो अब वो कुछ रेट से भाग रहा है, ठीक है, मान लो वो 10 किलोमीटर पर घंटे से भाग रहा है, धीरे भाग रहा है, अब VC2 भागेगा 30 किलोमीटर पर घंटे से, लेकिन वो आधे घंटे के टाइम पे रहेगा तो उससे पीछे ही ना, तो हमेशा रहेगा उससे पीछे ही. So now C2 is getting charged at faster rate, but VC2 is still be lesser than VC1. Okay, and what is your IR2? IR2 is VC1 minus VC2 by R2. That means VC1 is also increasing and VC2 is also increasing. VC1 is also increasing and VC2 is also increasing, but VC2 increasing at faster rate. That means IR2 is decreasing, right? IR2 is decreasing, but IR2 is still positive. IR2 is still positive. Why so? Because IR2 is still positive. Why so? Because VC1 is more than VC2. Do you understand it? Look, what is happening here is that initially your IR2 current is 0 and IR1 current is 5 by R1. So that current charges capacitor C1, and because of that VC1 is developed. And VC1 is developed, now here we have Vin. So since VC1 is increasing and Vin is constant, that means your IR1 is decreasing. So since your VC1 is increasing and Vin constant, so your IR1 is increasing. So from t equals to 0 plus only, your IR1 is always decreasing. Okay, so your IR1 is always decreasing, and since VC1 is developed, and because of that some IR2 current is developed. VC1 is developed, and because of that some IR2 current is developed. And since that IR2 current is developed, so first the IR2 current will decrease for some time, and after that it will decrease. Okay, why so? Because your IR2 is VC1 minus VC2 by R2. Your VC1 is also increasing and VC2 is also increasing, but your VC2 is increasing at a higher rate. Why so? Because your VC2 is getting charged with current IR2 and your C1 is getting charged with current IR1 minus IR2. So your VC2 is increasing, but that is lesser than VC1. That is VC2 is increasing, but it is lesser than VC1. Okay, so now VC2 is trying to reach till VC1. Your VC2 is trying to follow VC1. Okay, your VC2 is trying to follow VC1. It is still lesser than VC1, but it is increasing at a higher rate now. Okay, so now it is increasing at a higher rate, so your R2 will go, so your IR2 is going down. There will be no point where your IR1 will be equals to IR1. At steady state only your IR2 will be equals to IR1. This point we will see in end. Okay, we will see this point in end. Okay, so now your VC1 is also increasing and VC2 is also increasing, but VC2 is increasing at a faster rate, so your IR2 is decreasing. Okay, and IR2 is still positive. So both IR1 and IR2 are positive but decreasing, and VC1 and VC2 both are increasing but VC2 is increasing at faster rate, right? VC2 is increasing at faster rate. At steady state and along with that VC1 is greater than VC2. At steady state VC1 will be equals to VC2 equals to 5 volt and IR1 equals to IR2 equals to 0 ampere, right? Both current will go down to 0 and both the capacitor voltage will go up to 5 volts. Okay, so let us draw the output waveform. So before that there will be one question. Let me write it down. Which capacitor will reach the steady state first, C1 or C2? So people will say that which capacitor will reach steady state first, C1 or C2? So what people will do, people will say that VC2 is following VC1, right? VC2 is following VC1. So first VC1 will be, so first C1 will be reached at steady state and after that C2 will follow it and C2 will be reached at steady state. But this is wrong. Okay, the answer is both reaches the steady state at same time. Okay, now let me explain it with some example. Assume at t equals to t1 we have at t equals to t1 c1 has reached steady state. So vc1 will be equals to 5 volt. Also assume at t equals to t1 c2 has not reached steady state. That means your vc2 is at some 4.99 volts. Okay, at t equals to c1 what we are assuming is that c1 has reached the steady state before c2. Okay, so we are assuming that c1 has already reached a steady state. So if c1 has already reached a steady state, your vc1 will be 5 volt and vc2 will be 4.99 volt. So what will be your IR1? IR1 will be 0 ampere, right? This is 5, this is 5. So IR1 will be 0 ampere and IR2 will be 0.01 by R2, right? And your IR2 will be 0.01 by R2. So now what you see here is that so here we have 0.01 by R2 current and here we have 0 ampere current. That means this 0.01 R2 current should have to flow from here, right? This 0.01 by R2 current have to flow from here. Here we have 0 current and here we have 0.01 by R2 current. So this 0.01 by R2 current have to flow from here. This 0.01 by R2 has to flow from C1. That means it discharges the capacitor C1. But capacitor C1 never get discharged. That means the assumption was wrong. Assumption was wrong. Okay. So the capacitor will never discharge, right? The C capacitor will never discharge. It will always charge. So we assume that C1 has reached the steady state first, and then C2 has reached the steady state. Okay. There is one more point is that if you are saying that C1 has already reached the steady state, and after that you are saying that C1 is getting discharged. Okay. First you have said that C1 has already reached the steady state. Then you are saying that after that C1 is getting discharged. So that means the C1 hasn't reached the steady state, right? Look, here you have assumed that C1 has reached the steady state, but now you are saying is that the C1 is discharging. This is not possible, right? You are saying C1 has reached the steady state, and now you are saying the C1 is discharging. So this is not possible. So this is contradictory. Okay, contradictory assumption. So that means so there has to be only one condition that both IR1 and IR2 goes to 0 at same time. Both IR1 and IR2 goes to 0 at same time. So there this condition has to be there. So only at that time you will have the steady state. Okay. So this can be asked. Okay. So now let me draw the waveforms. Yeah. So drawing the waveforms now. So let us start from IR1. So initially IR1 was 5 by R1, right? So starting from IR1. So initially it was 5 by R1, okay, same was IC1, and then eventually it goes to 0. Okay. So starts from 5 by R1 and eventually it always decreases and goes down to 0. Right? This is IR1. Now talking about IC1. IC1. So talking about IC1. Initially it was 5 by R1. IC1 initially it was 5 by R1 and eventually it goes down to 0. But IC1 will always be lesser than IR1. Right? Because IC1 was IR1 minus IR2. So your IC1 was IR1 minus IR2. That shows your IC1 was lesser than IR1. So it starts from this value and goes down to 0. Okay, go down to 0. And talking about IR2 and IC2. So IR2 is initially 0. What is the color? Brown. Initially 0, then it increases and then it goes to 0, but always lesser than IR1. Never goes equals to 0. It goes equals, never goes equals to IR1. Okay, IR2 is always lesser than IR1. If IR2 is more, then the capacitor C1 starts discharging. Look, IR2 is, this IR2 is always lesser than IR1, because if IR2 is more and this is less, that means the current will flow in opposite direction. That means the capacitor discharges, but this never happens. The capacitor C1 always charges. Since capacitor C1 always charges, IR2 can never go above IR1, or never go above equals to IR1 as well. Okay, IR2 can never go equal to IR1. It will go equal to IR1 only at steady state. Okay, so at steady state IR2 will be equal to IR1 and both will be at 0. Both will be equal at same time, right? So it will go something like this. Okay, so all have reached the steady state. This is IR2 is equals to IC2. So steady state is reached at same time. Steady state is reached at same time. Okay, now talking about VC1. Okay, we will talk about VC1 first. So initially capacitor is 0 and eventually it charges to 5 volt. Okay, so it starts from 0 and then charges to 5 volt. Okay, so this is V, not here, I should write like this. This is VC1. Now talking about VC2. Talking about VC2. So initially your VC2 is 0 for some time, right? It is 0 for some time. Then it starts charging and goes to steady state at same time. So this is VC2 or V0. Okay. So initially it is 0 for some time. 0 for some time. Okay. It is 0 for some time. Then it charges. Then it follows VC1 and goes to steady state at same time. Steady state reached at same time. Steady state reached at same time. What else we need to do? We need to draw. It is VR1. So talking about VR1. So VR1 initially was at 5 volts, right? Initially capacitor was 0, so it was at 5 volt. Then it goes down to 0. So this is IR1, so VR1 will go something like this only. Okay. And talking about VR2, VR2 will go same like IR2. Okay. So So it will go up and goes down to 0 like this. So this is I R2, this is I R2, and in green color this was I R1. Okay, so I hope now you have understood all the concept. Okay, and none of the graph here is exponential. No graph is exponential. Okay, so these are all the cases. Okay, so I hope you have understood the concept. Now we have seen one more circuit in the previous videos. We saw one more circuit, this one, right? R1, C1, and one buffer R2 and C2, right? This is buffer. Okay, now here because of this buffer, your VC1 will reach the steady state before VC2, because here there is no current of IC1 and IC2. It's because here there is no concept of current IC1 and IR2, because here this current and this current are equal. Here let's assume V in as its type input 5 volt. Here IR1 is equals to IC1 is equals to I1. Okay, and this I2 current is also same. IR2 is equals to IC2 is equals to I2. No relation between IR1 and IR2. That means VC1 will reach steady state first, then VC2 will follow it. Okay, and which graph will be exponential and which will not be exponential, that I have already explained, right? So VC1 will be exponential and VC2 will not be exponential. Okay, so that I have also explained. So that's it about all the RC circuits. So they can't ask more from here. Okay, this is the max they can ask. They can't ask more, that I can guarantee. So this is the max they can ask. So now you are comfortable with all the concepts of second order RC circuits and also first order RC circuits. Okay, so I hope you have understood the concept now. Okay, thank you.